Hello, hope you're having a good day. Today we're looking at graphing quadratic functions 1b. Now, the only difference between yesterday and today is yesterday I gave you the x values to plug in. Today I'm going to show you how to choose your own x values. Now this method is specifically for graphing quadratic functions. You wouldn't go through all this trouble if it was, say, a linear function or exponential. But for quadratics, this is just a good method. And you'll see if I read the instructions, the method is very simple. We're going to find the axis of symmetry and the vertex, and then we're going to use that axis of symmetry value as the center value of our table. So let's just get right into it. So what do I mean? Well, if I need to find the axis of symmetry, we know I'm going to have to identify A and B. A is 3, B is 18, and of course, I'll just go ahead and put C as 20 anyway, even though I don't need it right now. And I'm going to do the axis of symmetry on the side over here because I know I'm going to need my space on the right-hand side later. Axis of symmetry is negative b over 2a, and if I haven't said this yet, at this point you should hopefully have that memorized. It will not be given to you on the next test. I'm going to plug in b is 18, so negative parenthesis 18 over 2 times a, which is 2 times 3. Negative 18 is what we get over 6, and that simplifies to negative 3. So that's the first part of finding my vertex. What I need to do next, to find the vertex, I'm going to take that negative 3, plug it into the original equation. So let me go ahead and move this down here. So I'm going to have y equals, and it's a good tight pinch here. Sorry about that, guys. 3 times negative 3 squared plus 18 times negative 3 plus 20. I could go a little onto the graph because I know it's not going to cover the whole graph. Negative 3 squared is positive 9. 9 times 3 is 27. Positive 27. 18 times negative 3 is negative 54 plus 20. This simplifies to negative 27 plus 20, which ends up being negative 7. So I end up with the vertex negative 3, negative 7. And I will write that down. And I'm going to want to plot this point right now. So starting from the origin, negative 3 means 3 to the left. You count it 1, 2, 3. And then 7 down, 1, 2, 3, 4, 5, 6, 7. Put a point here. Now you guys don't need to make those marks. I'm going to go ahead and erase those now, but I know some people had asked me where actually, if I could show how it's doing the points. So that's the point. Now and that's not new. I want to remind you that's what we did last Thursday. Assuming you did the work from last Thursday. Now, we're going to add to that is we're going to take this value, negative 3, negative 7, and that's going to become the center value in our table, negative 3, negative 7. And I'll erase that. I don't really need that. And so if that's my center value, what I need to do on either side of my negative 3 is I'm going to put the two numbers before negative 3 and the two numbers after. And it doesn't matter what order you do them in. It should be negative 3, negative 4, negative 5, and negative 2, negative 1. So again, what did I do here? I took my vertex, which was the point, negative 3 and negative 7. And I said, okay, I know that the vertex is the exact center of the graph. If I know that's the center of the graph, I want that point to be at the center of my table as well. Then, if I build out to the left and to the right, I know that I'm going to have the two sides of my parabola. And again, how do I do that? I did from negative 3, negative 4, negative 5, negative 3, negative 2, negative 1. There's the two numbers on either side of negative 3. Now, I do have to do the substitution, and it's a pain. Like, you're right. It is not fun. It's not hard, but it's a bit of a nuisance. I agree. If you have your calculator, you know you can type most of this in exactly the way it looks, and it should be able to handle it for you. It's going to do this, so this is going to give me y equals negative 5 squared is 25 times 3 is 75. 18 times 5 is negative 90 plus 20. This becomes negative 15 plus 20, which is negative 5. So I got negative 5 here. Oh, I'm sorry, positive 5. See, I was hesitating because that sounded wrong to me. Right, so it's positive 5. And let's do the next value. Plug in negative 4 squared plus 18 times negative 4 plus 20. Negative 4 squared is 16. 16 times 3 is 48. 18 times 4 is negative 72 plus 20. And that's going to be y equals positive 4. No, negative 4. Now I'm going to pause here. I'm going to graph these 2 points. So I'm going to go back. Negative 1, 2, 3, 4, 5. And then up 5, 1, 2, 3, 4, 5. There's my point. And I'll pause. Sorry, really didn't mean to rush you. And erase that. I don't need that. And for negative 4, negative 4, I'm going to do the same thing. 3, 4, and then 4 down. The point right here. And I'll erase that as well. Now, what am I expecting here? Well, since I know this point is a vertex, I know the vertex is the center of the graph, what I expect then is that I'm going to have 2 points on this side that match the 2 points on the left. And if you are confident in that, you could just go ahead and write that those numbers match. Now, I'm going to go ahead and do the substitution anyway, just to be on the safe side, but they should match. So let's just see that that's true. Plugging in negative 2, 3, negative 2 squared plus 18 times negative 2 plus 20. 2 squared is 4. 4 plus 3 is 12. So you have positive 12. Negative 18 times 2 is negative 36 plus 20. Well, 12 plus 20 is 32 minus 36 is negative 4. So I do get negative 4 here, which is what I expected to happen. And then again, if everything goes as I expect, I also am pretty confident that I'm going to get 5 for the last value. Let's just see if that's true. Y equals, I'm going to plug in negative 1 this time, so 3 times negative 1 squared plus 18 times negative 1 plus 20. Well, that becomes 3 minus 18 plus 20, and that is indeed positive 5. And again, is this always going to be true? Well, it is always going to be true if you put the vertex in the middle. So keep in mind, I started by finding the vertex. So if you find the vertex, and if you're talking about a quadratic equation, or rather function, then you should see that symmetry, and we're going to see that same symmetry in the graph. When we graph it, negative 2, negative 4, I'm going to go back to down 1, 2, 3, 4 to here. Get that nice mirror image point that I expected to see. And then for negative 1, 5, back 1, up 1, 2, 3, 4, 5. I get again a nice point right here. And I erase there. And there you see a nice symmetric graph. Now what are we going to do to finish this? We're going to do our best job to draw a smooth curve through all 5 points. And we're going to try to make the point the vertex not too pointy. And I'm just going to do my best job here. Actually, let me zoom in a bit and I'll make it easier for me. And then drawing curve, and then right there, it turns around. And of course, it needs arrows on both ends. I'll tell you, it keeps going on forever. So there it is, problem 1 for graphing quadratic functions, 1b. Again, the goal is that in the end, you're going to be able to graph a parabola completely on your own. And honestly, that's all you need. By the next assignment, we'll do it a slightly different way. But this graph is a good graph. I'd be happy with it. All right, thank you.